Hello Internet, my name is Quinn, and this is Blondihacks. It's been a while since I've done a tool build, so I'm going to start a short series today on why is that car so loud? Your car isn't cool, it's dumb. Hello Internet, my name is Quinn, and this is Blondihacks. It's been a while since I've done a tool build, so I'm going to start a short series today to make a float lock vise. These things are really cool, and I'll show you how they work right now. Some projects have an inspiration. This one has an anti-inspiration. The source of my hate-spiration is this standard drill press vise. Why these things are the standard, I will never know because they're basically terrible at everything. The jaws on them are sloppy, they have this great big clearance behind the fixed jaw so you can't put parallels in them. The jaws are too big for small pieces and too small for big pieces somehow. And the bolt down flanges are always in the way, and I don't know, somehow these vices manage to be terrible at everything except maybe drilling cross holes in 1-inch square tubing. That's the only thing I've found them to be pretty good at. The solution might be this handy gadget invented in about 1951 by the Float Lock Vise Company. It's a vise where the jaws can float into any position on the drill press table, and then when you tighten the clamp on the back, it presses the jaws down against the table, locking it in place, hence the name. Then 70 or so years later, Mr. Pete went and made a version of this, and as part of his project, one of his viewers made drawings for one of these vices and shared them in the public domain. So I've got those drawings linked down below if you would like to have them, and I'm going to make one of these vices based on those drawings. I'm going to start right in the middle here where there's a smooth guide bar and a lead screw. Those two parts kind of dictate the position and dimensions of all the other parts, so it seems like a good place to start. Now I'm going to actually make the smooth guide bar first, even though it's trivial, because I have this length of drill rod that I want to use for that, and it's just barely long enough for this. It might be a little too short, we'll see. And then I've got a piece of 1144 stress proof here that I'm going to use for the lead screw. Now this guide bar is a 12-inch length of precision ground drill rod from McMaster, and because I ordered it at the exact length that the drawing calls for, it might be a little too short, and if it is, then I can adjust the lead screw to match, so that's why I'll make the smooth bar first. This part is trivial. All I need to do is clean up the ends, and I've got some shim stock there to protect the stock from the jaws because that ground surface from the factory is the finished surface that I want. So just go ahead and face these off, as is tradition. And then I'll break those sharp corners with a file to make it look nice and feel nice. Before I stop though, I'm going to check the dimensions of the end here in a couple of places. One of the things you got to watch for when you're working close to the end of factory stock is if it was pinch cut, then the end might be distorted. If it was bandsaw or cold saw cut, then it won't be. So you got to check that and make sure there isn't like a little flared end on it or something that you might have to machine down to get past. But that looks good, so I'm going to flip that around and do the same thing on the other side. This tight tolerance stock is guaranteed to be within half a thou of the specified dimension all the way down the length, and it's precision ground, so it has an excellent surface finish on it. It's nice stuff, saves you a lot of work. And then I'll just use a little acetone to get rid of that factory paint there on the ends. Moment of truth, how long is this thing? And turns out it's actually still too long, which is good news. McMaster gave me a 100 thou bargain on this stock. So now I'm going to face it down to the final length, and I'm going to show this in detail because this is one of those things that tripped me up when I was first learning machining, is how do you get something to an exact length in the lathe because you can't measure it while it's in the machine. So you take it out of the machine, you measure it, then you put the end of the tool on the stock, move it clear, and then set up an indicator on the carriage, and then move the carriage over the amount that you need to remove. Then I like to re-zero it on that position with less than one full rotation of preload. And that eliminates error when you're reading the indicator. You don't have to keep track of how many needle rotations you've done. And then you just face down to 0 on that indicator. You could of course also do that with a DRO, but you don't need a DRO to do this. And if you're experienced, this is all obvious, but it's just one of those things that I think beginners can get tripped up on if you've never seen how that's done. Final check here to see what length I landed on, and you can see that we're right on according to the guessometers, so you can see that method is very easy and very effective. Okay, time to get ready to cut the Acme thread on the lead screw. So I've got a piece of high-speed steel here, and I'm going to grind an Acme thread cutting tool in this. I've never cut an Acme thread before, so I don't have the tool. The way I like to do these kinds of tools is just glue up the piece of high-speed steel, and then I just trace the thread profile right off the fishtail gauge, or in this case the equivalent gauge for the Acme thread, right onto the tool. As you can clearly see through my transparent thumb there, I've traced the 29-degree angle there. And since it's much narrower than the high-speed steel chunk, then I'll just draw a straight line across there, and that gives me the area to grind away. Then I looked at how much grinding that was going to be and redid that on a much smaller piece of high-speed steel because I don't want to be here all day doing this. Quick dress of the wheel so that it's 10% less embarrassing, and since I didn't get it all dressed up for nothing, let's grind a tool bit. Now you can use miter gauges or D-bit grinders or all sorts of fancy methods for grinding perfect threading tools. Honestly, I just grind them to the lines, and for a hobby shop, that works extremely well. It takes a little bit of practice, but the secret is really a good tool rest. I built that tool rest you see there in a 4-part video series that I'll link to below. It's an older project, but it served me extremely well. It's got a miter slot on it because I thought I was going to use miter gauges for everything, but honestly, with a little bit of practice, it just isn't that hard to grind decent tool bits to a scribe line. Grinding is very slow, so there's plenty of time to compare it to the fishtail gauge and just keep making adjustments until it's perfect. Once I've got those angles right, then I just square off the tip because it's an Acme thread, and you can check that using the sides of the gauge there. It's got a little notch for each size of Acme thread. Just double check that the tool fits into the main part of the gauge there. That looks good. And then the end should fit into the number 10 slot there because I'm cutting a 1/2 inch 10 Acme thread. So far so good. I've also biased that thread cutting tool to the right because I'm going to be using it upside down, as you'll see here in a moment. Now I will rough cut the stock to length here. Again, this is that 1/2 inch 1144 stress proof. I'm not going to be machining the OD of this because I'm just cutting a thread in it anyway. Most of the OD is going to be removed, so I just bought the stock at diameter. I'll start by facing off the end and putting a center in that for tail support. I'm going to switch out to the collet chuck now. It'll give me a little better concentricity and grip there on that part. And just make sure I've got enough pulled out for the length of the entire lead screw. That looks good. Tail support seems to be running good. We are ready to go. To start with, I need to put some long shoulders at each end. One end goes into the fixed jaw on the float lock vise, and then there's a little stub boss on the other end that runs in a bearing. So I'm using the indicator on the carriage there to measure the travel for the entire length of the shoulder. And away we go. This should be a very simple shoulder turning operation, but of course nothing's ever entirely simple. This piece is so long and so thin that even this simple turning operation is starting to chatter as soon as I get even a little bit further away from the tailstock support there. So I'm going to have to do something different with my setup even for this simple feature. So I brought in the steady rest just to give myself a little extra rigidity close to the cut there. And that solved the problem nicely there, so I'm getting very nice cuts. I'm using 1144 stress proof here, which is basically cold rolled steel that's been normalized so it doesn't tend to warp after machining, and it also is very strong in tension and compression, so it seems like a good choice for a lead screw. My final OD there is just a hair over what it should be, so I'm going to bring it down to final dimension with emery, and that also is a nice excuse to improve the finish there. Might as well. Now I'm going to pre-cut the little boss at the other end. The reason I'm doing these end features first is because they're going to give me starting and run out areas for the thread cutting, so it's kind of convenient to cut them now. I'm rough marking this one long with the ruler because I don't actually have a way to precisely measure something this long, so I'll just leave it long and I'll trim it down to final length later, as you'll see. But right now I just need a little groove here to start the thread cutting in. Well, no more procrastinating. It's time to swap the change gears so that we can cut this thread. Change gears are a bit of a hassle on these small lathes, but with practice you do get a lot faster at it. So this doesn't bother me nearly as much as it used to. And on this particular lathe, it's a pretty easy process. As you can see by this actual speed footage here, swapping out from the feed gears to the 10 threads per inch thread cutting gears so that I can cut this 1/10 Acme is pretty quick indeed. In fact, I finished it just in the time it took me to explain what I'm doing. And once again, this footage is actual speed. So once you get the hang of it, it goes very quickly. At this point, I did a test part because I've never cut an Acme thread before, and I'm glad I did because the first one on the right there is a hot mess. I made 10 different mistakes, which I will enumerate for you shortly, and then the one on the left is the second attempt, which went extremely well. So I had to build my confidence doing this before I try it. There's my Acme thread cutting tool upside down because I'm going to be cutting left to right with the lathe running in reverse, which is a much lower drama way to cut threads if you have the ability to run your spindle in reverse. And then I have to square up the tool just like you would with normal thread cutting using the Acme equivalent of the fishtail gauge here. A light really helps do this accurately. It's much more accurate than doing it by feel. So I just turn the tool post until that lines up with the edge of the tool there. And then I know that the thread cutting profile that I ground is square to the work because it's probably not square to the shank of the tool, especially because, as you saw, I just freehand traced that onto the tool. Unfortunately, though, I have a clearance problem here. My tool holder is too big and I don't have room to get into my groove there. But this is the perfect excuse to show you another way to square up the tool bit, which is to loosen the tool bit in the tool holder and square it up this way and then tighten down the grub screws there. This allowed me to move the tool bit to the outer edge of the tool holder because it's a very small piece of high-speed steel, and that gave me the clearance I needed to get in the groove, so to speak. And now that I'm in my groove, let's do a scratch pass and see if the thread pitch is correct. Now, I actually already know it's correct because I did those test parts, so you wouldn't normally do your scratch pass all the way down a long piece like this just in case it's wrong, but in this case, as you can see, it is correct. There's my 10-pitch Acme thread gauge. That looks good. This is a really good time to check the clearance on the tool post as well on the tailstock, because if you run out of room here halfway through your thread, you have to try and extend that tool bit and pick up the old thread without messing up any of the alignments of everything, and that's very difficult to do. These are all things that I did wrong on my first test part. Now, this is a long, thin part, so the follow rest seems like the way to go here. So I'm bolting this onto the carriage. It's going to give me support all the way down the length of my lead screw here. The follow rest is great for long, thin thread cutting operations because you need to do it in one continuous cut. If it's just a turning operation, you can use a steady rest and work on the shaft in sections. But with thread cutting, you need some sort of rest that can move with the tool because you have to do it all in one cut. That's where the follow rest comes in. Unfortunately, and I know this about follow rests, but I always forget, they take up a lot of room on the left of the tool, and so you need extra stock there to give clearance, and I always forget. And unfortunately, I didn't have another piece of this stock so that I could cut a longer one for this setup. So I had to come up with an alternative since the follow rest wasn't going to fit. I started out by just taking some very light cuts to see if I could get away without using the follow rest, and I got a couple of passes down this way. I did a 2 thou cut and then a 1 thou cut, and it was working, but I was starting to hear some hints of chatter towards the middle of the shaft, so I knew I wasn't going to get away with this for long. The thing about thread cutting is even with the compound at the correct angle, the deeper you go, the heavier the cut gets because the leading edge of that tool is taking a bigger and bigger slice on the leading edge of the thread surface. So while this last cut was running, I did some experimenting with different things, and I found that actually running a ball bearing tool here on the back of the work while it cut was actually helping a little bit. So that gave me some ideas to try, and what I ended up landing on was this. So I've got a chunk of brass here with a hole and a split at one end so I can clamp it, and I plunged an end mill the same diameter as my stock down the other end. And this is going to give me a little brass shoe that I can run on the back of the work using a magnetic indicator stand. Now the stand is mounted on the far side of the carriage because that's where it has to go for clearance around the chuck. So this is kind of like a follow rest, but it's not really doing anything for rigidity. The thing about a machining operation like this is you've got two things you're fighting. You're fighting deflection in the work, which affects the dimension, and you're fighting chatter, which is caused by a standing wave that builds up in the machine. So rigidity is an easy solution to both those problems, and that's what the follow rest is giving you. However, if you don't have the luxury of solving both problems, you can solve them one at a time. So deflection I can solve by just taking very light cuts. For the chatter problem, this brass block running on the back of the work is just disrupting that standing wave. It messes with the harmonics and doesn't allow that standing wave to build up, which creates chatter. So for my next couple of passes, just the brass block on there worked great, eliminated the chatter. You could actually hear the chatter try to start, and then it would die again. When the cuts got a little heavier, deeper in the thread, then I found just applying a little bit of light pressure with my hand on the block continued to eliminate that chatter. When it got deeper still, then I just started lightly squeezing the brass block into the tool as it ran. This actually worked quite well. And the deeper the cut got, the tighter I had to squeeze, but it really didn't take a whole lot of pressure for this brass block to just disrupt that harmonic and prevent the chatter from starting. This was a Hail Mary, honestly. Like, I ordered longer stock to give myself clearance for the follow rest, but while I was waiting for the stock to be delivered, I tried this and it worked. So here we are. I used lots of cutting fluid as well, because that also helps eliminate chatter. Before I landed on this, I also tried rigging up some kind of temporary follow rest with some scrap stock or something. But the thing about this particular lathe is there just isn't room on the carriage anywhere to do that easily, so it would have to be a pretty complicated structure, which I wouldn't be able to easily build here without losing my setup. And because I'd already started cutting the thread, I had to keep going with this setup, so I had to hack something together, as it were. But eventually what I'd like to do is maybe build a different type of follow rest that can sit directly behind the tool on this lathe. It has to be something that attaches to the carriage, not the cross slide, because you need to maintain constant distance to the work with the follow rest, not the tool. What the heck is an Acme thread, you might be asking? It's a basic trapezoidal thread form that was invented in 1894 as an alternative to the square thread. It's in the category of power screws or lead screws. These are thread forms that are designed for transmitting power. The canonical version of this is the square thread, and the square thread is the most efficient because the torque applied to the screw is converted almost entirely into lateral force on the nut. However, square threads are extremely difficult to manufacture because the tool clearance angles required are difficult to achieve. So the Acme thread was invented as kind of an evolution of the square thread. It has a shallow 29-degree angle, so it's almost square, but that angle allows tool clearance, makes it much easier to manufacture. And there's some other benefits as well, such as easy compatibility with half nuts and better adaptability to wear and so on. But this is why you find Acme threads on clamps and vices and things like that. But hey, even a blind monkey finds a mass damping system sometimes, and that actually worked really well. So here's a final check here with the thread pitch gauge, and that looks really good. Checked it in a few spots just to make sure it was consistent, and I took some measurements just to make sure that deflection hadn't caused it to be, really fat in the middle or something like that. But everything looked good, so I think I got away with that. And I will definitely be building a better follow rest in the future, but until then I will just clean up the leaning tower of Chipsa here. To finish that up, I'm also going to hit the outside with some emery. Remember that the OD was left the black mill scale that the stress proof comes with. So because the very outside of that thread was never machined, I'm just polishing it up here to make it look nice. And I'm pretty pleased with that. I think that might work. I'll finish that up by chamfering the end, and now I can part off the other end here. Now because this part is so long and thin, I've left the other end in the tailstock while I part, and I'm not going to part all the way through. I'm going to stop short there, and then I'll finish it with the hacksaw. It's not a good idea to part things with the tailstock in place, but I don't want to leave this long, thin part dangling while I part it off either. So put a board down there to protect the ways, and Yahtzee. This little contraption saved the day. So you got your steady rest, you got your follow rest, and I dub the goofy rest. One more detail here, I need to remove some of the threads at this end because I left that intentionally long, which was, in hindsight, a silly way to do that, but it's how I did it. Now this caliper is not long enough to measure the entire length of the part, so I'm measuring from the edge of the thread there because I know exactly how long the thread is supposed to be. So I'm marking that distance right there on the high spot of one of the threads. Then I can face this boss down to that point. So flip it around here in the forejaw. I've got the soft jaws on there to protect the thread. And that piece of tape is just marking which thread I put the scribe line on because it's easy to lose if the light isn't just right. And dial in on that stub there. Now I can take my grooving tool and with some magnification I can line it up precisely on my scribe line there. I don't know why I used a grooving tool for this. It was just in my head because that's how the feature was originally made, but this could have been done with a regular turning tool. Anyway, machined that down to the same level as the boss, and then did use the turning tool to face it down to final length. Quick check on that depth here, and perfect. None of these dimensions are super critical, but, you know, make them as good as we can. A little chamfer there, because chamfers are what separate us from the animals, and that lead screw is looking very fine indeed. Now, we do need some cross holes in both of these parts, so I'm going to bring in one of my favorite little fixtures that I've made. This is my cross drilling fixture. I have a video on making this, which I will link to below. Cross drilling round stock can be very annoying, but a fixture like this makes it super, super easy. The secret sauce to this thing is that the V-groove in the center is extremely accurately in the center of the entire fixture, to within a couple of tenths. Watch the video on making this to see how I did that on hobby-grade equipment, and that allows you to edge find on the edges of the fixture and know you're going to be perfectly centered on that round stock. If the end of the stock is not accessible, as it sometimes is not in this fixture, then I just slide a gauge block in there, and then I edge find on the gauge block. The gauge block is touching the stock, not the clamp there. And then I just add the size of that gauge block to the radius of the edge finder, translate over, and there's the edge of my stock right there. Now I translate over to where the hole needs to go, and poop knuckles. Yes, sometimes it doesn't line up nicely with the hole in the clamp if the cross hole is near the end of the part. That's okay, this fixture works in other ways as well. I can slide the stock down, stick the end out that I want to work on, find that edge again, and then I'll just stick a little machinist jack in here with a sacrificial scrap to support the end, since we're hanging out in space a little bit more than I would like here. Because we're drilling on a convex surface, I start by center drilling to create a little dimple there so the drill doesn't wander off the top surface, and then I can pilot drill through there for the reamer, and then I'm going to come in with a reamer to finish these holes. These holes are for cross pins that pin the various structures to the jaws, and also for pinning the crank onto the end of the lead screw. The other place this fixture really shines is if you have multiple cross holes to drill, as I do. So I can just slide the next piece in. The smooth bar needs 2 cross holes in it, and it's already centered up in the y-axis. So I just had to edge find on the x-axis for the location of the hole, and I can once again center drill, and ream that through. Flipping the bar over, I realized I'd made a mistake here. I need the second hole to be aligned with the first one. What I should have done is used something like a rose index, and this is a fixture that you can clamp onto the bar before you drill the hole, and it gives you reference edges that will be parallel to that hole after you've drilled it, so then you can create other features that are parallel or square to that hole. Now, the rose index is something that a lot of people copy, but this is the real deal from Tim Rosenthal. So if you want a rose index, go ahead and order one from him. I'll link to that below. There's a lot of clones out there, but this is the original, so go ahead and patronize a small business who deserves your business. Since I didn't do that though, I'm going to hack my way out of this problem as well. I've got a piece of drill rod here that's a very close fit in that reamed hole, and I'll use that to square up this hole vertically against the table there. I'll start by doing it by feel, but then you always want to bring in light as well. Your feelings will lie to you in this and so many other ways. So use light to see that gap there and get things really well aligned, and that should be hopefully good enough. That was an unfortunate failure to plan ahead on my part, but the other hole at least is lined up with the clamp, so I can use this fixture in its entirely intended fashion. And there we go, 2 cross holes in the smooth bar. Now I just need to deburr those holes, and I still haven't found a way to deburr holes on convex surfaces that I'm very happy with. I end up using the Noga tool here and just kind of rolling the stock back and forth to try and catch the edges, and that works okay. You know, you end up with a chamfered hole, but the chamfer is a little cattywampus, so I don't know, don't tell Stefan, and maybe we'll say that's okay. So there's my final little Acme thread lead screw and matching smooth guide bar. That was a lot of fun to make those 2 parts, I have to say. And look, you can just buy Acme threaded rod, but, you know, where's the fun in that? I'm really glad I got to try my hand at cutting an Acme thread, and I'm pretty pleased with how that went. We'll see how good it really is when I make the matching nut, if all of my dimensions were right, but until then, I'm going to pretend it's perfect. Thanks for your support, especially my patrons who make all this possible, and I'll see you next time.